Welcome to Happy Sparkle Glitter Fun Zone. I'm Russell Hay, and I'm going to talk to you about LEDs and JavaScript. That's really loud. So we saw robots. Robots are cool, but hardware can be intimidating when you're first starting out. And so this talk is actually all about adding a little sparkle into your life. And I'm having problems with my device today, so give me just a second. It'll work later. So today what we're going to talk about is the options that are available for RGB LEDs, how to control them, and then we're going to build software to control the lightning rod using Johnny 5 and NodePixel. Now I call it the lightning rod because I have problems getting dressed in the morning. I never know whether it's going to be hot, cold, rainy. I mean, it's Seattle. The weather's kind of unpredictable. And from this talk, there's three things that I really hope that you can get. As a place to start working with hardware, enough knowledge to actually experiment and play, and inspiration to go and make something that's useful to you. So let's talk about pixels. It's working again. So the type of LEDs that we're talking about are individually addressable RGB LEDs. We call them pixels because, well, they're like pixels on a monitor. And there are two different types. The type that we're going to actually talk about is the WS2812, or NeoPixel, as Adafruit calls them. They've been around for a good long while, so they are the cheapest option that's available. They are also the most common. If you see tutorials about how to work with individually addressable RGB LEDs, chances are they're going to be the NeoPixels. They're supported by a whole bunch of different libraries and different languages. And the nice thing about them is they actually only use a single I/O pin. So if you're working with really small microcontrollers and you only have like 3 pins, it's great because you can control 128 LEDs with a single pin. The other thing that's great about them is that they have all kinds of different form factors that you can get. Christmas lights, meteor lights, grids, rope light, rings. Pretty much if you can think about something that you want for NeoPixels, chances are they probably have them. But with all hardware, you have a bit of trade-offs. Because we only use that one I/O pin, timing of the signals that go to the LEDs are actually really, really critical. And so you can't do anything on the device while you're updating the LED strips. And if you're working at 30 or 60 frames per second, that doesn't give you a lot of time to do anything else. And if you have hardware interrupts, you have to actually turn them on, or turn them off during the time that you're actually updating the LEDs. The other thing about the NeoPixels is that they're actually a little bit susceptible to power fluctuation, so the reliability goes down if your power supply isn't like super rock solid. Now, imagine if you want to take a bicycle, put some LEDs on the spokes of your bicycle, and ride it around to create images. With the NeoPixels, the refresh rate, because of the way that the timing signal works, it's actually too slow to actually do those persistence of vision effects, and so you would end up getting a broken up image on your bicycle if you were going to use those. However, there's another type of chip that's relatively newer than the NeoPixels, and they're APA 102C, or dot star, or super LED. It seems like people can't figure out what to actually call them. And the nice thing about them is that they're actually a really fast refresh rate. So they are usable in that instance where you want to make pictures with your bike. And the reason that they have the faster refresh rate is because they actually use an external clock. So they use 2 I/O pins, and then you actually control the signal, the clock signal, as well as the data signal. So you get a lot more control over what's happening on the little chip that is embedded in the LED. Now, of course, dot star has a bad side. They are more expensive. They're about twice as expensive as NeoPixels. And so as you start scaling up the number of LEDs that you're using, it gets costly. And then when you ruin them, because you reverse the polarity of the power, it becomes a cost. They're also not currently supported by NodePixel, but I am working on changing that sometime soon. And if you want them in a strip format, that's awesome. They're available. If you want them in any other format, it's going to be a little bit harder. They don't actually make them in very many form factors. And of course, if you're working on that tiny Arduino or other microcontroller that only has 3 pins, you're using 2 of those to control the LEDs instead of just 1. So that's the 2 options that are really available for this type of LED. And there's also, likewise, 2 different ways of controlling them. You have your self-contained, where all of the code is running on the microcontroller and you have no other computer associated or sending any information to the device. Or you can have a host computer. We're going to actually talk more about the host computer, but I want to give you kind of the options that are available. And for self-contained, it's great because it's very minimal parts, right? You have your Arduino, you have a couple of other components that we'll talk about in a little bit, and you have your pixels, and that's it. But it has its bad sides. You're limited to printf style debugging. Because most microcontrollers have only a little tiny bit of memory, you're actually really limited if you want to start doing keyframe animations or anything like that. And almost all of them are programmed in either assembly or C, or some variation of a C-like language. And so memory management is completely manual. A lot of times on embedded systems, though, you just allocate all the memory up front and don't worry about memory. But the good thing is, with self-contained, if it's battery powered, you can actually do things like shut down the processor whenever you're not updating the LEDs to save power, which is actually kind of nice. And there's a few different options for self-contained for programming against the LEDs. FastLED is probably the most widely used library. It supports both the NeoPixel and the dot star, but it's a little bit beginner unfriendly. The Adafruit NeoPixel library is actually much more user-friendly, and so it's very straightforward and easy to learn. The last option is you could actually write it from scratch, but I don't recommend doing that. You're going to pull your hair out because it's not fun. But self-contained is great, but you know what? There's actually an easier way, and that's what we're going to cover. And that's having a host computer. And the host computer communicates with the Arduino that then communicates with the LEDs. And there's some great benefits to this. You have tons of memory. It's easy to debug. You can use higher level languages like JavaScript. You know, you're using your own environments, the IDEs or editors that you're used to. You're not restricted to a more stripped down version of an IDE like you would be if you're using the Arduino IDE or anything like that. But trade-off, you have more components. It's a little bit more complex to get set up, and a higher power requirement because now you have 2 processors involved. Ooh. Sorry, skipped ahead. So the options for host computer, almost everybody nowadays for this type of thing uses Firmata if you're going to have a host computer communicating with it. Johnny 5 is actually based around Firmata for doing the actual control on the Arduino. NodePixel actually has its own firmware that you can upload to the Arduino that allows a little bit more direct control than Firmata. But where it really shines is when it's Johnny 5 plus NodePixel. We're using Firmata to actually communicate with the Arduino, and you get all of the power of Johnny 5, including the animation library and other things, when doing it this way. So that's what we're going to actually cover. But before we get into the software, let's talk a little bit about the hardware. There's 3 things that you always want to do when working with NeoPixels. You want a biggish capacitor, and I'll show pictures of this in a moment. But you want around 1,000 microfarads across your power line, and this just helps even out the power when the LEDs first come on, they have an initial kind of current surge, and so this helps just kind of even that out. Likewise, you want to put a resistor on the data line that goes to the NeoPixels to actually protect the first pixel. The first pixel has a tendency to actually burn out if you don't have the resistor. I'm kind of ignoring that in this because I didn't put it into the circuit. And then the last thing that you want to do is always calculate the power usage. These particular LEDs use around 30 milliamps per LED if they're full bright white. I'm a little paranoid when it comes to power, so I usually double that. And so on this stick, I have 128 LEDs at 60 milliamps per LED, and that's around 7.5 amps. And my power supply is 8 amps. I like to have a little headroom when it comes to power so that I don't have to actually worry about it. But there's rules. You can break them. I'm breaking them here. Kind of a rule of thumb for me is 16 LEDs or less, and you can actually forget everything I just said. You can power them directly. You can actually, at 16, you can actually use the onboard 5-volt regulator on the Arduino without much of a problem, as long as you don't turn them all on bright white, which most people don't anyway. So now we're going to talk about hooking it up. So it's actually really simple. There's a 5-volt line on the Arduino. Or on the NeoPixel. There's a VIN on the Arduino. You connect those together, and you connect that to the power line of your power supply. There's ground and there's ground. Connect those together. Put the capacitor between them. Data in on the NeoPixel goes to pin 6 or whatever pin you want. I always use pin 6 just as a kind of convention for myself, with the resistor in line. So this stick actually is using the Adafruit Metro Mini, 128 LEDs. It has a 1,000 microfarad capacitor, and it's an 8 amp 5-volt power supply. And it looks something like this. Actually, this is a picture of it. And so, as you can see, we have our Arduino, we have our capacitor. The NeoPixels are obviously off screen. And then there's the 5-volt in the ground. And if you haven't worked with hardware before, the lines here are actually all bussed together. So that's why you see all of these wires here, because this is distributing power in multiple places onto the strip. It's usually a good idea just to do that so that you're not just relying on a single wire delivering power to the entire strip. So why Johnny 5 and NodePixel? Really, it's because it's easy to learn. It's very straightforward. There's a lot of resources and a great community surrounding it. And of course, because it's JavaScript. So here's the very basic boilerplate of how you get set up with Johnny 5 and NodePixel. So in Johnny 5, you create a board. You do, basically, it emits an event called ready. And once that's ready, then you can actually create your strip. And you do things like tell it that we're using the Fermata version of the controller, and that it's on pin 6 and it's 128 LEDs. And then when the strip is actually ready and initialized, it actually emits its own ready event. And then at some point, you do something. So do something, and there's a little bit of a delay, but this will start blinking in a moment. It's buffering on the serial port. So do something, in our case, is going to be blinking eventually. So we just set an interval, and we call it every 500 milliseconds, and we're going to blink it blue, eventually. The two things that really I want to, oh, there we go. The two things that I actually want to call out on this are this strip.color and a hex code for the color. In this case, it's a kind of toned down blue because these LEDs are actually super bright. And so strip.color actually sends the same color to all of the LEDs. Now, the other line in here is this strip.show. And strip.show doesn't actually, or strip.color doesn't actually display anything on the LEDs. It just queues up the state of the LEDs at the next time that it's going to update update the strip. And so strip.show actually says, OK, I've set up everything, send it out to the device. But you know what? Static code is actually boring. So let's look at live code. So this is the exact same code that we just saw, a little bit reorganized. And instead of blue, it's going to be red. And it's enumerating the devices, finding out where the Johnny 5 or where the Arduino is working or existing. It's doing its handshake so it knows what's actually on there, and then it starts blinking, which is awesome. Okay. I have to kill it at the right time, otherwise it'll stay red. Okay. So let's actually build something useful. Now, I alluded to this, that I'm really bad at figuring out what to wear. I actually kind of wish I was wearing my hoodie right now because it's kind of cold up here. But I'm going to build what I'm calling the lightning rod, and it's an ambient display that can live in my environment and help me guide my clothing options in the morning by telling me what's the temperature for today and is it going to rain? Because those are usually the two things that I mess up. I'm usually in shorts when it's like 60 out, or I'm wearing a hoodie when it's like 80 out. So that's what it's going to do. It's going to tell me if it's going to rain today, and it's going to be the average temperature over the next 4 hours. I've encoded the temperature using kind of my comfort zones. The colors don't actually show up exactly right here versus here because LEDs are different than projectors or different than screens. But essentially, we have blue is I'm going to be cold, cyan-ish color. It's a little hard on the LEDs, but is kind of my comfort zone. 60 to 70, I'm usually okay. 70 to 80 is great shorts weather. Anything over 80, and I might as well just get in a refrigerator or something. So I'm using forecast.io to actually get all of that information. I've just wrapped it to make it easy so that I don't have to show you like, oh, the API key goes here or whatever. And it's actually based on Semiamu. So I have it hard-coded to Semiamu's longitude and latitude. So let's take a look at temperature. So let's get past the boring part. So this code is actually mostly the same as the code we just saw, except for that now we're going out to forecast.io. We're fetching the forecast for, well, it's like the next 8 days, but I'm only using the forecast for today. We're averaging the temperature over 4 hours, and then we're mapping it to that color range that we saw. I'm also logging it to the console so that you can see it. Hopefully, I actually have network. Yeah, okay. And then now, it's going to be the same blinking, except for that now, the color that's blinking is going to be the color of the temperature. So let's take a look at that. That's supposed to be cyan, even though it looks blue. So we're actually in some pretty good weather, somewhere between 60 and 70. But you know what? Blinking lights in my house, that would be really annoying really quickly. So let's actually take a look at how we can make that better. So same code as before, except for now, there's this breathe animation, or breathe function that we're passing the color to. So let's take a look at that. This is a whole bunch of math. I'm not going to go over the math because I found it online, and while I sort of understand it, it's a bunch of math. But essentially, it uses the sign function to modulate the color over time in a cyclical manner. There's some exponential stuff in there to make it, a little bit more pleasant of a breathing. And I'm just applying that same thing to the red, the green, the blue channels, recombining it back into a color, and then putting the entire stick that color. So let's take a look at that. Okay, so hopefully it's visible. I've really kicked up the intensity of the breathing so that it should hopefully show up. Okay. So for me, I could have something like this in my environment. This wouldn't annoy me or my dogs. So that's great. We now have the temperature. What did I just do? Let's just reload. Okay. So now the next thing I want to do is figure out, is it going to rain? Now, I think a nice breathing stick is good for a sunny day, but for a rainy day, probably not. So I actually want to animate it so that it actually, so that it'll actually rain, or look like it's raining from the top of the stick down. Eventually, this will be covered in a translucent tube, so it'll actually, I think, give a really nice effect once it's diffused a little. So let's take a look at that. So this code is significantly different than the previous code, but And I'm not going to cover too much of this. But the thing that I want to call out here is this line. What this line says is, I've got the strip. Give me a pixel at this index. It's 128 LEDs, so they're indexed from 0 to 127 linearly. There's a whole bunch of other functions that help me treat it more like a grid than just a linear strip. But what strip.pixel does is it gives you a handle to an object that is a specific pixel on the stick. And then you can call the color method to actually set just that pixel to that specific color. And again, it takes a hex code for color, just like everything else. Again, with this, it sets up the state, and then you have to call strip.show once the state is all set up. The other thing that I want to show is my rain animation, which again, it's a whole bunch of math. It's slightly easier math, we're just doing a bunch of averaging. But I want to tell you the story about how I came up with this effect. And actually, while I'm talking, I'm going to start it so you can see it. What I did was I basically had a rough idea of what I wanted to do. I wanted it to look like it's raining. And then I sat down and figured out, okay, well, how do I do that? Because I have no clue how to actually do that. And so I spent a lot of time just sitting down and doing an attempt to make this. It didn't look right the first time. It didn't look right the 100th time. But what I would do is I would make small changes and rerun it and see how it looked. And I would get close to what I wanted, and then I would just continue to experiment in small steps. And that's really what I would like, what I really want to encourage people to do is working with hardware, and LEDs in particular, is really about a lot of experimentation. So where to go now? I mean, we could do things like, I had a friend whose bar just got, he owns a bar and it just got hit by a tornado. Wouldn't it be great if a tornado warning could be encoded on the stick so that you know that there's tornadoes in your area? It's okay, he's fine, the bar's fine. Or you could hook it up to other sensors. The great thing about Johnny 5 is it allows you to add other sensors to this and just bring it all in to a single system that can then use the LEDs to visualize it. And that's great. How much time do I have? Oh, perfect. That's pretty much the end of the talk. I have a whole bunch of resources that I just want to call out that helped me learn. The first one is just the Adafruit NeoPixel Uber guide. I mean, it's pretty much like everything you need to know about working with NeoPixels in particular. AJ Fisher's NeoPixel library is great. It's actually how we can control it from JavaScript. Johnny 5, of course, awesome. And I have stickers for Johnny 5 if anybody wants them. I put some out on the table, but you can also find me if there's none left out there. Ray Wu's AliExpress store is pretty much where I get all of my LEDs from. It's significantly cheaper than buying it from anywhere else, even with the shipping costs from China. And he has all kinds of different options and all kinds of different things that you can find. And I also have links to the specific LEDs that I used here, the board that I used, the power supply that I use. I won't talk about the light stand. That was just to make it a little bit more visible. The slides are available on GitHub. You can find me on Twitter at Russell Hay. My GitHub is Russ the Aerialist. I have a blog that I don't use very often. All right, thank you.